In this video, I'll show you how to use GeoGebra to compute normal probabilities. In this video, we'll focus on right-tail probabilities. So first, let's go to the website geogebra.org/classic#probability. We want to be on the distribution tab, and we want to have the normal distribution selected from the drop-down boxes. We'll edit the mean and the standard deviation to what we need. I have some examples worked out already. According to a study, the average number of faces an adult can remember, recall the face and remember the name, is 150. Let's assume a population standard deviation of 30 faces and a normal model. So that means that we can go to GeoGebra and use a normal distribution where we have a mean of 150, so you can replace whatever number is shown up automatically with 150 and then change the standard deviation to 30. We want to find the probability that we can remember at least 200 faces in this part. So the word at least means at the very least 200 is the number of faces that can be remembered, but then anything greater than that is also okay. So the least is 200 and then it increases from there. So in GeoGebra, we need to select a right tail probability because on a number line, the left is lower numbers and on the right is higher numbers. So we'll start from 200 and increase, so that means a right tail. So we select the box for the right tail probability. You can even see the tooltip when you hover over it says right-sided. Then we can drag the little triangle of the divider between the purple and the white region over to about 200. You may have a hard time getting exactly 200, so you can edit the box down here on the bottom. Probability of 200 is less than or equal to x, which is kind of a weird way to write it, but you can also read this as x is greater than or equal to 200 if you read from right to left. So push enter, and we'll get our probability. So 0.0478. So that's about a 5% chance that someone can remember 200 or more faces. If I were to work this out by hand, I would draw my normal model, put in a mean of 150, here's my cutoff of 200, and remind myself that the standard deviation is 30. Then I would compute the z-score for the cutoff of 200. I'd take 200 minus 150 and then divide by 30. So remember, when you type this into your calculator, you want to do subtraction first, get your answer, and then divide by 30. If you type it in literally 200 minus 150 divided by 30, you will get 150 divided by 30 first, because that's order of operations, and then that number is subtracted from 200. You'll get a crazy number that won't make sense. So remember, do your subtraction first and then division. So 50 divided by 30, we get 1.67 for a z-score. So then on a table, like in the back of the book, or you can look up any normal table online, we want to find the area to the right of 1.67. So in the back of the book, you would look up the row that says 1.6, like I've written here. Then you'd look up the column of 0.07, because if you add up those numbers, you get to 1.67. So the row of 1.6, the column of 0.07, and you'll find an answer of 0.9525. So 0.9525 is the area to the left of 1.67. That's not the answer we need. We want more than. So we have to do some subtraction. The total area under the curve here is 100%. So if you take away the 95% that's to the left in this giant tail, then you get the area to the right, which is the smaller amount, 0.0475. But this is the answer from a table in the back of the book, and it's because we had to round our answer. We had to round the z-score to 1.67. Technically, that 6 probably went on forever, so we got a more precise answer with GeoGebra, and the answer from the table is rounded. That's okay, they're pretty close, 0.0475, 0.0478. They're out to the fourth. Correct the third decimal place. The fourth decimal place is a little different. So there we go. We found the area in the right tail of a normal distribution with an example.